Hey everyone, and welcome to our lesson about proofs. This is a continuation of 10.6, and earlier on in this lesson we talked about some general properties and ideas about justifying your steps, and today we're really going to formalize it and talk about proofs. So a proof is a convincing argument that uses deductive reasoning, and a proof logically shows why a conjecture is true. Okay, so the big idea here is that we're trying to use a convincing argument to show that a conjecture is true. Oftentimes we'll use a two-column proof, and a two-column proof lists each statement on the left, the justification or the reason for each statement is on the right. Each statement must follow logically from the statement before it. Okay, so most two-column proofs will look something like this. I'll actually have two columns, and this side could be the statement, and then this is the reasoning behind that statement. And we'll use things like our properties of equality. We'll use the transitive property, reflexive property, things like that to justify our statements on the left. And we're all trying to work to what we're trying to prove at the bottom. So let's look at an example. We're given here a segment, and more importantly, we're given that C is the midpoint of AD. All right, because we know that C is the midpoint of AD, that tells us some things about our expressions. It tells us things about AC and CD. So the given is very important to us. When we look down into the box here, you can see we have our statements, we have our reasons. The first statement is that C is the midpoint of AD. We know that because it's given to us. And the given will always be that first reason. We will state the given. The reason is it's given to us. Okay? Now, we're kind of helping you along here. The definition of midpoint AD is the reason. All right, so what potential statement could we make? Well, because C is the midpoint, we now know that AC is equal to CD. All right. Reason being, that's the definition of midpoint. Okay. Now, because AC is equal to CD, we now know that these expressions are equal to one another. So 4x, which represents the length of AC, is equal to 2x plus 12, which represents the length of CD. This is the substitution property. All right, we'll just shorten it to say substitution. Now, we are on a quest to solve for x here. I can see that I'm going to use the subtraction property of equality, so I can write this equation down here. We can kind of see how it'll be solved. So if I'm going to use the subtraction property of equality, that probably means I'm going to subtract 2x from both sides. When I subtract 2x, I'm going to be left with 2x equals 2. So that's what I'll write here in my statements. 2x equals 2. And I know that because of the subtraction property. All right. Now, I need to make a small change here. This should be 12, not 2. I apologize. All the way through here. Now, to go ahead and finish solving for x, I'm going to divide both sides by 2. All right, so I get x equals 6. How do I know that? That's the division property of equality. I'm going to do shorthand for the equal sign there. All right? Now it's your turn. Go ahead and try giving the reasons for solving for x here, and then check your answers. All right, so as always, the first reason is given. Okay, now I'm going to write this equation down below here just so we can clearly see what's going on. My first step is going to be to subtract 1 from both sides, and I'll get 5x equals 20, which is what I've got right here. So what did I do? I subtracted. This is the subtraction property of equality. All right. Last step would then be to divide both sides by 5. So I get x equals 4, which again is right here. That was the division property of equality. All right, moving right along. I'll actually take this one and do it for you. It's a little bit longer. Let's go ahead and fill in the statement. The reason is given. What was given to me? I was given that Km is equal to 35. Let's look at what Km is. Km is the length of this segment here. It's the full length of the segment. All right. Let's also look at what we're trying to prove. We're trying to prove that KL, which is this portion of the segment, trying to prove that is equal to 15. So let's get started. If I know that Km equals 35, I also know that KL plus LM equals Km. That is the segment addition postulate. All right, we talked about that earlier this year. That says if I just add two parts of any segment, I get the whole segment. Now it says I'm going to use substitution. So I'm going to take KL, which is 2x minus 5, and add it to LM, which is 2x, and say it's equal to Km, which is 35. I just substituted in the expressions for the lengths of the segments. Okay, now I'm beginning to solve. Okay, when I add my two x's together, that's just combining like terms. So I'm going to write combine like terms. Okay, now the addition postulate or property of equality says that I need to add to both sides. So I'm going to be adding 5 to both sides, and I'm left with 4x equals 40. All right. Now I've got to divide both sides by 4, so that's the division property of equality. Okay. Now I found out that x is equal to 10. Okay. Now I've got to figure out what KL is. So I'm going to take 10 and I'm going to substitute it in, right, up here, and I'll find out that KL is 15. So that is the substitution property. Okay. Hopefully you're starting to catch on here. We've got one more example I'll do with you, and then you'll do some packet work. So here we go. I'm given that the measure of angle 1 is equal to measure of angle 3. The reason? It's given to me. Okay? Now, the measure of angle 1 plus the measure of angle 2 is AEC. Measure of angle 2 plus the measure of angle 3 is the measure of angle DEB. How do I know that? That is the angle addition property. Okay? It says I can add two smaller angles and get the larger angle. Okay, now I make the jump to say that the measure of angle 3 plus the measure of angle 2 is equal to AEC. If I look right here, here's how we find the measure of AEC. Okay, instead of the measure of angle 1, I have the measure of angle 3. Since 1 and 3 were the same, I substituted 3 in. This is the substitution property. Okay. Now, from here, I say that the measure of AEC is equal to the measure of angle DEB. Okay. If I look up here, DEB is the same as the measure of angle 2 plus the measure of angle 3. Okay. So I can use the transitive property to determine that AEC is equal to DEB. And again, that's because the measure of angle 3 plus the measure of angle 2 is equal to AEC. The measure of angle 2 plus the measure of angle 3 is equal to DEB. Therefore, these two have to be equal to each other. All right, there you have it, folks. There's a little bit about proofs. Go ahead and complete that packet work and check your answers and come to class ready to ask questions.